Thank you very much, Dave. It's good to now have a shiny spot with you. So, first time in Perth, delighted to be here. Thanks for the great weather. Somebody said you had 320 days a year of sunshine? Yeah, bullshit. No, it's great to be here. And went out and made my first acquaintance with a quokka yesterday. That is one weird animal, but cute. Marsupials is such a strange concept, but yeah, anyway. My name is Kent Beck. I work at GOTO, which does small business payroll and benefits in America, which turns out to be a lot more interesting than that sentence sounded. Especially in America, the complexity of tax regime is just incredible. And while we don't have the kind of computational challenges that some scaling companies do, we do have very interesting domain modeling challenges. How do you represent 9,000 different taxing authorities in the US, including one shopping mall that has its own income tax in Ohio. So sorting that out, watching a small company get big has been very interesting. And one of the things, I'm glad Dave mentioned my relationship with Ward Cunningham. When I was just a wee little programmer with hair, I hooked up with Ward at Tektronix Labs, and we had a very fruitful collaboration for 2 or 3 years that really changed the course of my career, changed the trajectory of my career. And I realized, I'm about to tell you a story about my time at Facebook and the critical question that I learned to ask there. But most of what I did at Facebook that was really visible and obvious was reinstate the kind of mentoring relationship that I had had with Ward at Tektronix Labs. And this is something we as a technology community used to just sort of understand organically, that it's the job of the elders to teach the youngers when they come out, that software development is not a production process, it's a learning process. And anything that we can do to maximize learning, including coming to conferences like this, going to meetups, trying out things, reading books, big fan of reading books, and not only because I write them, but that whole emphasis on learning, and especially generational learning, is something that we lost and something that I'm trying to bring back to the places that I work and the relationships that I have with what are now inevitably younger programmers. That kind of, when I came out, you would sit down, there'd be some crusty old person saying, shut up, and don't touch my keyboard. And that was the beginning of the learning journey. And at first you were only annoying, and if you'd ask questions and make suggestions, and eventually you'd get the patterns of what was going on, the rhythm of development, and that was passed through the generations. That's not something, somehow we've gotten collectively the idea that if you're not programming, you're not being productive. So everybody should be, let's all divide up, we'll program as fast as we can, and then something good's gonna happen. And that limits the opportunity of people to learn. It limits the opportunity of the seniors to develop their understanding. As you explain things, you inevitably learn more, and it limits the ability of the younger programmers to grow their skills, whether technical skills or the so-called hard skills, social interaction and so on. Those are the hard skills, right? Like learning how to, another refactoring, that's easy. Learning how to be empathetic, that's hard. So we should call them correctly, the hard skills and the soft skills. Soft skills like, you know, type inference and stuff, and hard skills like talking to people. So, in any case, so that's my short soapbox in favor of if you're the senior where you are, it's your job to help the juniors learn and to program. If you're the junior, it's your job to learn and program. If we can all, as a community, get behind that model of programming instead of this factory hamster wheel model that somehow has taken hold, we're all going to achieve more of the tremendous potential that there is in software. Okay, I said end of soapbox, and I really mean it, so I could keep talking about that for a long, long time. This is some kind of joke, right? Okay, here we go. So in 2010, I was living on a goat farm, as one does, in Southern Oregon. No, actual goat farm with actual goats. You should have seen my forearms. They were just massive from milking. And if you ever want cheese made, I'm definitely your guy. And I got a call from a recruiter and said, there's this company, Facebook, they're looking for senior engineers. Would you be interested? And I've heard of them. At that point, Facebook was quite successful, but it wasn't clear that they were going to grow to the degree that they did. So I said, sure, I'll go and interview. And I went and had a series of interviews. And over the course of the day, I discovered this odd engineering organization. They were doing very few of the things that I would expect effective engineers to do. There's very little unit testing. There were no estimates. There were no deadlines. There was very little technical collaboration in a way that I would recognize it. And yet, they were being remarkably successful. And nothing gets me going like a good mystery. Something like that where this is a bumblebee, it shouldn't be able to fly, and yet it's flying. I want to dig into that. So I got an offer, and January of 2011, I showed up to my first day of boot camp at Facebook. Now I learned lots and lots of lessons there. And so I have to focus on one because I only have an hour of your attention, maybe less. We'll see how it goes. I wanted to understand this contradiction between they're not doing what good engineers should do, and yet this incredibly complicated system is up, running, stable, growing, scaling. New features are being introduced on a consistent basis, some of which are wildly successful. Like, how can all that stuff happen if you're not doing the stuff that good engineers do? And so I dove in. The first feature that I implemented was domestic partnership and civil union in relationship types. You can say, I'm in a domestic partnership with so-and-so. I typed, these fingers typed domestic partner. The feature was rolled out. There was an immediate bug in it in spite of all of my testing, which I did careful testing, unlike these bozos, which wasn't enough. They were forced to make a hot fix rollout because there was still a bug in my code. That's embarrassing. Then there was a news cycle around this. You know, Facebook introduces alternative relationship types, followed by a right-wing backlash. Facebook attacks traditional values, followed by a left-wing backlash. Facebook tries to normalize something less than complete marriage equality. And then I'm thinking, but these were the fingers, and I just typed domestic partnership. I was not intending to attack traditional American values, but there you go. So that was my first feature. And one of the seductive things as a programmer working in that environment is that you can do the kinds of things that you're used to doing as a programmer, write a program, and have visible social impact. Now, it turns out this has a downside, but I'll get to that towards the end of the talk. But it felt great to be part of an application that was creating value for so many people. By the time I'd left, 1.5 million people were using those relationship types as part of their expression of their identity. And that felt great to me to be a part of that. So I show up, I've written all the books, done all this stuff. They're not doing the things in the books. I don't mind if people don't do the stuff in my books. I just want them to fail. So what is this? I thought, okay, about a week in was the first hackathon. And I thought, all right, you guys, I'm here now. Everything's going to be okay. I will give a class. So different people could sign up to give classes at hackathons. I'll give this class, and I'll talk about test-driven development. Because after all, who wouldn't want to take a class on test-driven development from me? So I went and looked towards the end of my time at Facebook. I looked at the actual sign-up sheet just to make sure I'd remembered correctly. The class just before mine on the sign-up sheet was Advanced Excel Techniques, and it was completely full with a wait list. And the class just after mine on the sign-up sheet was Argentinian Tango, and it was completely full with a wait list. And I had precisely 0 people sign up for my TDD class. I know. So I thought, wow, what am I going to do here? I rolled out my first feature, and it had a bug in spite of everything that I tried to do. And other people rolled their first features out, and they didn't write tests, but then they were just fine. And then I tried to say something to this community, and they weren't interested in listening. How am I ever going to have any impact here? So I took the most frightening decision of my career. I said, I'm going to forget everything that I know about software engineering, and I'm going to see if I can learn this weird thing that they're doing that's clearly not software engineering. I'm going to see if I can learn it fast enough to not get fired. And that worked for 7 years. And then it stopped working. But that's another story that I'm not going to get to. So I just monkey see, monkey do. This is one diff, right? No. That's like 4 diffs. Oh, okay. And this code's fine, right? No, you definitely want to put that behind the feature flag. Really? Yeah, okay. So just as I programmed, I would look at the people to my left and to my right and say, well, how are you doing things like this? And I just copied what they did. Because there was no other way, one, that I was going to untangle this mystery, and 2, that I was going to have any impact myself on the organization. It was about 5 years later that I finally parsed out what was going on at Facebook. This one question that I didn't know to ask before I started developing. And so how that worked, so here's the thing about ideas. There are no new ideas. It's like Balanchine said about dance. There are no new steps, but there are new combinations. There are no new ideas, but there are new combinations of ideas. So anytime I come up with something, an idea that's new, it's inevitable a combination of things. It's not just one thing that pops into my head. So here's an example of that. I had this mystery of how does Facebook engineering manage to continue to deliver both operation, scaling, and innovation at the same time. And I'd listened to a podcast with Nassim Taleb in which he talked about convex and concave payouts. Is this anybody familiar with convex and concave payouts? Excellent. Nothing's worse than building an entire talk around something and you say, has anybody heard of this crazy, weird idea? And all the hands go up and you're like, well, what am I going to do for the next 45 minutes? Anyway, so here's the distinction. A convex payout is one where you make a small investment and most of the time you lose everything, but it's small so you don't care. And every once in a while you win big. So a lottery ticket, venture capital. Those are things where you make a small investment. You don't have an expectation that any one of them is going to pay out, but integrated over a portfolio of these, something's going to pay off so big that it'll pay for all of the little losers. If you're in a convex world, oh, and by the way, this convex and concave thing, this took me like 6 or 7 years to figure out. So if you draw this curve where you get lots of little losses and one big winner, and you have a little person stand right here and look up at the curve looks convex to that person. It's 6 years. I'm really slow, but I'm persistent. By gum. Okay, so that's the convex world. If you're in a convex world, your best strategy for investments is to put a little bit into each idea. Because you don't know which one's going to be the big payoff, if you leave any idea out, that might have been the one that would have paid for everything else, and so you lose. In a convex world, you can't predict which one's going to pay off. I remember a story of a big bank buys a trading desk and discovers that 90% of the profits are generated by 5% of the trades. And down comes a memo that says, stop making the other 95% of the trades, which you can't do. Just to jump to the end of that one. This is a convex world. You can't know. Careful analysis is never going to show you which one of these investments is going to be surprisingly valuable. It can't. So your best bet is to invest in more, to get more coverage over the space of all the possible investments, and then one of those is going to pay off and big and pay for everything else. Contrast that to these concave investments. A concave investment is one where you make a relatively large investment that's going to have a relatively small payout compared to the investment. So mortgage lending is one of these. You got the spread between the interest that you pay or now don't pay and the interest that you collect on the loan. And that's a relatively small amount, but it's very likely to pay off. Every once in a while, though, you're going to lose everything. Some banking crisis will come along and poof, away it all goes. If you're in a concave world, where generally you know a lot about the investment that you're making, then if you don't analyze carefully, you're making a big mistake. You're leaving money on the table. So you should carefully think about each investment before you make it, and because there's a lot of money riding on each investment that you make. Also, if you want to improve the payout of the portfolio as a whole, if you can limit your losses on those big losses, that's hugely valuable because that has an outsized effect on the payoff of the portfolio as a whole. And again, if you have this concave curve and you stand over here and you look up, it looks concave. So I had heard this podcast, it had gone into my head, this distinction between convex and concave, and I couldn't figure out where the little person would stand so that the metaphor of convex and concave would make sense, but I just put that in the back of my brain and let it percolate. Went to Facebook, started relearning software engineering, began my coaching career. I ended up coaching a couple hundred of engineers at Facebook, which is its own set of stories. But I had this mystery of how does this bumblebee fly? And I don't remember the exact moment when these two ideas collided, but at some point I realized, oh, Facebook treats different projects very, very differently. And sometimes even week to week. So a project will go in for a review and get a, hey, you're making great progress. They'll go in a week later and say, hey, we're doing more of the same stuff, and just get eviscerated. Like, no, why are you still doing that? Like, this seems inconsistent. What is going on? And I realized, oh, this convex-concave distinction explains the behavior that I observe. And here's how it works. When you begin an idea, a company, a product, successful companies have this logistic curve where it's flat at the beginning, steep growth, and then diminishing returns towards the end. And what creates that shape of curve is actually the tug of war between two feedback loops. You have a positive feedback loop where growth fuels more growth. And then you have a negative feedback loop where more growth makes it harder to grow further. And depending on how big those two loops are, and when they kick in, that generates the shape of this curve. In the early days, when you're just exploring new ideas, you try something, you try something else, you try something else, you try something else, you try something else. And then you do something that looks to you just like the last 8 things that you've tried, and the reaction to it is completely qualitatively different than what you've done. This is the exploration phase. So, for example, when Eric and I wrote JUnit, we were on a plane from Vienna to Washington Dulles to go to the UPSLA conference in Atlanta. And we'd each written 100 programs, just sat down and started a program. And I was showing him this testing framework that I'd come up with. He was showing me Java. We programmed for a while. And came up with something that looked interesting. Like the code looked good. We handed a floppy disk with JUnit on it to Martin Fowler when we got to the conference. And the next day we had 30 people clamoring, oh, we heard you did some cool thing with testing. Can we get a copy? And immediately had to go and make more floppy disks and hand this thing out because you could. That's how you distributed software. We were advanced enough that we didn't charge for it. So we were that far in the future. We were just, okay. So that's an example of a successful exploration in the sense that we'd written a bunch of programs before. We just wrote another program. In the moment of writing it, it didn't feel different. But the reaction to the program was way out of proportion to any reaction that we'd seen before. That's living in this convex world, where you're just trying a little bit of this, a little bit of that, a little bit of this, and then you do something and it just blows up. My tweets are another example of a convex world where when I press tweet, I don't know what the reaction to this particular tweet is going to be. I can't analyze it ahead of time. I couldn't build some complicated model that will say you'll get this many impressions for this tweet. So if that's true, my best strategy is if I think of something that seems tweetish, I should just put it out there, because who knows, this might be one of the ones that blows up. That's the behavior that I should have in this exploration phase. I can't analyze my way to success. I can only experiment. And the only failed experiment is one that I don't learn anything from. So earlier I said successful exploration, and that's I don't even like that word for explorations. If we are drinking beers and we have a crazy idea and we try it out and nobody cares, that's successful. As long as we didn't spend any more time than we had to get that answer. The mistake in exploration is trying to be successful. Let's refine it more and be more careful and analyze more carefully. And if you do that in exploration, you're costing yourself a whole bunch of other experiments that you could do. There is a discipline of exploration. There's an engineering discipline of exploration. So if you're trying to minimize latency from asking a question to getting an answer, there's a way to do that. It may or may not involve writing tests. It may or may not involve careful refactoring. If you can cut corners and get an answer in exploration, you should. That looks very different than traditional engineering, kind of the, carefully refactor everything. If you're carefully refactoring code and then you throw it away because the answer is no, then you shouldn't have carefully refactored it. That's exploration. Now at the other end, let's say we've taken an idea, it's surprisingly successful, we've scaled it, and we'll get to that in a second. Now we have this idea and we're continuing to grow. So we have 1/10 of the available market and we want to get the next 10th. That work looks completely different. In that work, we have a lot to lose. We don't want to mess up what we have, but we do want to grow. That means we have to change things. So we're going to continue to change things after careful analysis and with a lot of thought about the downside of what we're about to do. So when we're extracting value from a proven idea, we behave very differently. Something that looks much more like textbook software engineering. Something that looks much more like textbook project management, where we know, okay, we're going to try the following 4 experiments to see if we can improve growth by a little bit. Or we're going to introduce our product into the 14th country. When you introduce your product into the first country, if you carefully analyze and try and figure out exactly how not to make mistakes, you're making a mistake. Because you don't know. When you get to the 14th country, if you're still just, we'll just wing it, then you're definitely making a mistake because you have a ton of experience with which to refine that process of continued growth. Projects in those 2 different phases, exploring and extracting, need different engineering skills, oftentimes different people involved. They have different sizes of teams, different styles of project management, different models of funding. So exploration projects, we come up with a crazy idea, we should just be able to get started on it and work for a limited period of time. When the money's gone, the answer is no, unless the answer is yes. In which case, we'll all know that because it's going to be one of these, servers are falling down and phones are ringing off the hook and people are angry at us. That's great, right? When your customers are really angry at you. The enemy in exploration is indifference. Nobody cares about our crazy idea. If people are really mad because our crazy idea doesn't work quite right, they care. And being yelled at, like, no, somebody cares about my product. Enough to call me an idiot. Oh, I'm so happy. That is absolutely progress. It takes a little getting used to. So we should just try ideas. If we're working on a project that's in extraction, though, it shouldn't be all loosey-goosey. Like, oh, we have a payment system. I have an idea. Yeah. No, we're not. If you have $1 billion a month running through your system, you better be pretty careful about making some crazy changes to it. Because the first thing you want to do is not lose your success. You want to continue to grow it, but more importantly, don't lose it. So these two phases represent completely different styles of engineering, project management, finance, executive sponsorship, time frame, scale and number of people, scale and time. Everything's very different. One of the lessons that I learned, so this distinction is not magical. I mean, it's exactly convex and concave as applied to software projects. One style is not better than the other. The question that I learned to ask is, what do we have to lose? If you have nothing to lose, then just try stuff, because you don't have anything to lose. If you have a lot to lose, think very carefully before you try stuff. Work much more deliberately. Work long term. The trade-offs have all changed. Explorations don't last long. We'll try something, that doesn't work, delete it, go to the next thing. In extraction, this is code we're going to have to live with for decades in some cases. So the trade-offs all shift. We want to carefully refactor. We want to write lots of tests. We want to write documentation. That all makes perfect sense in extraction and doesn't make sense in exploration. One of the lessons of Facebook was that there is an intermediate stage. This vertical growth phase requires its own separate discipline, its own separate style of engineering, project management, finance, sponsorship, scale, so on. So let's say we've tried a bunch of explorations. One of them is shockingly successful. And now we're hitting some bottleneck to growth, this rapid vertical growth, and we just have to overcome that bottleneck. We don't have time to apply the perfect solution. We need duct tape. We need, I think the American phrase is chewing gum and baling wire. Is there an Australian equivalent? Okay, got it. So we just want to keep the system up and running. That's all. We don't have time to do it perfectly, but it's fine. You might say, well, no, I'm going to do proper engineering. You don't have time to do proper engineering. If you hit one of these bottlenecks to growth in this expand phase, and you don't overcome that bottleneck, your project's dead. And that's an extremely expensive mistake. Exploration is profitable because you have a few winners out of lots of experiments. So you have a small chance of a big payoff. Extraction is profitable because you have a large chance of a small payoff. Expansion is supremely profitable. It's the only time in product development that you have a large chance of a large payoff. But it's only a large chance, it's not a lock. Every time you hit a bottleneck to growth, you need to find some way to get around it so that you can get on to the next bottleneck to growth, so you can get around that to the next one, to the next one, to the next one. And that is its own style of engineering. There were people at Facebook who just loved that expansion phase. They didn't want to try out new products. They didn't want to try out, some crazy idea. what they wanted to do is they would just listen for somebody talking about a new bottleneck. That was not intentional this time. They'd listen for somebody saying, oh, you wouldn't believe the switch on the network switch on the top of my racks are catching fire and I don't know what to do. And they'd say, finally a problem worthy of my wizard-like powers. And they would dive in and get through that bottleneck, hit the next one, get through that bottleneck. Eventually, though, those problems become kind of mundane and sub-wizard-like powers suffice. And then they can peel off and find the next crazy problem that nobody's ever encountered before because of scaling. So that vertical growth phase it acts very differently. This explained this seeming inconsistency that I saw in reactions. So if our team is exploring some crazy ideas and we're covering the space of all ideas efficiently, then we should get good feedback. If one of those starts to take off and we don't notice the change and we keep exploring a bunch of crazy ideas and the one idea that really was going to work is now dying because we're not overcoming the bottlenecks to growth, then we should get yelled at. Even though we're doing exactly what we did last week, the context has changed. Now we have something to lose. We have this potential that we need to realize that we didn't even know existed before. And we should be called on the carpet if we're not taking this crazy exploration energy and focusing it in on the one thing that's actually working out of the 20 things that we tried. Similarly, once you get up towards the knee of the growth curve, when things start to become more rational and reasonable and predictable, if you keep just duct taping stuff together at a time when you've reached massive scale, then you're again wasting time, money, opportunity by not switching into proper engineering mode, and you should be called into account. So the hidden logic to Facebook's engineering and product development process was exactly that explore projects were handled very differently than expand projects, were handled very differently than extract projects. They were managed differently. In explore, you don't even know what the numbers should be to measure progress. So I remember an ads manager came to me, and this was further on in my tenure when this wisdom had started to slip a little bit. He said, well, I'm in an organization, I'm required to commit to a revenue, how much revenue my crazy new kinds of ads are going to generate. He says, either we generate 0 or 100 times our projection. That's the two. Well, if that's the case, saying to somebody, well, is it 17 million or 18 million is just a stupid question. It's like, how many experiments can you run and find the one that works surprisingly better than all the rest and focus in on that? That's the style in exploration. In expansion, you've got one problem to solve that you need to focus all your resources on, this next bottleneck to growth, get over that to the next thing, to the next thing, to the next thing. And in extract, you need a style that's more like OKRs, where you say, now we know the shape of the space. Now we know if we pull this lever, this needle goes up. So tell me how hard you're going to pull on this lever and tell me how much that needle is going to go up. And there's some balanced set of goals that you're going after. But it's very different styles. As long as they're treated differently, your organization can simultaneously continue to grow and scale the things that you've done well, explore new ideas that have unknown potential, and focus resources very quickly on those surprisingly successful ideas. What I see with most large organizations is that they get stuck in the extract world, right? The exploration world, that was 3 people in a garage and it's wild and crazy and you don't quite know what's happening and everything's a crisis, except you didn't know, because then you hit product market fit and now you're scaling faster and faster and now everything's a big crisis. And then finally, continued growth goes on, but you discover how to make that growth happen, but you apply those lessons to the previous 2 phases for the next idea and the next idea. Well, what does that mean? It means, well, I don't want you to go off for a week to try out a product idea unless I have an ROI projection. I'd like a monitor. I could lie to you and give you a number, or I could just spend the week and tell you what I learned when I'm done. That makes more sense. But no, grown-up, adult, responsible organizations are very, very careful. They don't want to waste money because we're spending a lot of money. So everything has to be treated like an extract project. And when that happens, the opportunities for innovation cease. But people are creative. They will go try stuff in spite of it. The ones that do happen to take off, the organization has no idea what to do with it. Because as you're scaling, you're working very inefficiently. Good job. Because I don't care how efficient it is. It's a rocket. It's lit. We don't know how high it's going to go. We just want to keep the rocket going. But that doesn't fit into this extract world. So all the organization's intuitions go into killing these projects. And then somebody else is out there, they know they don't have anything to lose as some startup, so they just try stuff. Most likely the startup fails. Every once in a while a startup succeeds. And then they're going to be the ones who take over from you. One of the things I liked about Facebook, and I'm going to get to the whole destroying democracy thing in just a second. But one of the things I really liked about Facebook is when we took over the Sun Microsystems campus, we took the sign that was out front and we flipped it over. So if you walk by or drive by, there's a big thumbs up sign. Cool. But if you look on the back side of that sign, it says Sun Microsystems upside down, as a reminder that nobody stays on top forever. Okay, so destroying democracy. Here's how that works. Part of, this is not a how-to, by the way. Actually, it may be. But anyway, we'll see how this goes. If you do manage to further destroy democracy, let me know how yes, Kent, it was at that talk. I'd be a little proud. Yeah, okay. Part of Facebook's culture is this magical word called impact. Impact means that every 6 months, you have to demonstrate with numbers what you did for Facebook, individually, you personally. Now, the big fear of people at Facebook was the free rider, kind of the person who sounds good but doesn't do anything, which frankly I got accused of being at times, but there you go. They were wrong about me, I'm pretty sure. So every 6 months, you're going to have to say, hey, photos uploads went up by 1% because of the features that I introduced. Or the cost of running this service went down by 12% because of what I did. That works great in exploration, because what it means is every single person is out there looking for what to do next that they can attribute to their own efforts. And you're all smart and creative people, and I want you all looking for what to do next. If I was the CEO and telling each of you your priorities day to day, like I'd be wrong and exhausted. And it would just piss you off. So lose-lose, let's not do that. Let's have everybody looking for what to do next. And this goal of being able to demonstrate this is my impact gives you incentive to go and look for a thing to do next. In expand, it also works well. In expand, you're dealing with this succession of bottlenecks, and you have to find the next bottleneck, and you have to overcome it. So if at the end of 6 months you can say, this service was falling over at this rate, and I introduced these changes, and then it was absolutely rock solid, that's a good piece of impact. When you get to extract, though, things start falling apart. In extract, at societal scale, the way Facebook is, where an appreciable percentage of the world's population is using the service every month, there's upside to the changes we introduce, and there's downside to the changes we introduce. When Facebook was just for a bunch of college kids, the downside's 0. Even as it's expanding, the downside is growing. But Facebook as an organization is still focused entirely on upside. You don't get any points if you avoid a problem at Facebook. That's not impact. Well, there was something, it was kind of risky, so I didn't do it. You're fired. And the people who are experiencing those incentives, they aren't bad people. They don't set out to destroy democracy. They set out to increase photos uploads by 1.2%. But what that means is all of you are out there adding a feature to Facebook Messenger on Android to do, the button goes like this instead of that, and that changes that. Everybody's looking for a little bit of upside that they can own themselves. And the downside is growing, growing, growing. The downsides are always some combination of factors, just like ideas. And it's nobody's job really to look out ahead and avoid those downsides. You're just trying to increase photos uploads, and you're trying to reduce the latency of some service by this percent, and everybody's trying to make things a little bit better. There's no incentive to avoid downsides. So if you say, well, there's this feature, and it would increase the number of messages sent, but it's a little bit, just feels wrong, so I'm not going to release it. You're in trouble in your performance review. And that's how Facebook incrementally, little at a time, went from really connecting the world more and more and more to having these outsized, it's this concave world where the downsides get bigger and bigger the longer you go. And organizationally, there's no way to address this because the focus on impact and this belief that every single person should be able to justify their continued employment every 6 months doesn't admit to good decision making. This moment where you say, there was this idea, it did some good things, but there's something's not right about this. Excellent, you did a good job of deciding not to do that. That's just not possible inside that context. And I believe, having been at Facebook for 7 years, I believe that there's no way they can, this is so culturally woven in, there's no way that they can avoid that. There's no way that they can grow past that and say, okay, we're a grown-up company now. We have to take more account of the upsides of the downsides than we do of the upsides. And if that means that our growth slows, then that's exactly what happens. The language, the metaphors, the mythology, the stories that are told around the campfires, all that's the hiring, who they hire, how people are enculturated, all that stuff is focused around impact. turning that ship around, I have no idea, and I don't think that they'll be able to do it. But I would predict that bigger disasters are to come. Although, given the current President of the United States, I cannot imagine what that would be like. So, in any case. Now, I'm an idea guy. That ended a little quicker than I thought it would, and I have a few more minutes. Are there any questions about what I've said so far? If they aren't, I got the next set of ideas to talk to you about. Oh, here we go. Just a second. We'll get a mic to you. Straight ahead.
You were talking about the expand part and how you fix things by band-aiding them, or whatever you want to call it. When do you remove the band-aids and fix them properly?
Yeah, great question. In extract.
Right.
When you get to extract, so an example at Facebook is, at one point, we had 5 different key value stores in production at scale at the same time. The API is exactly the same, get and put, that's all. Why did we have 5? Because 5 different explorations said to themselves, well, I'll just use this store, or I always wanted to write a key value store, so I'm just going to write one, or whatever. Those 5 were all winners in the lottery of ideas. They all scaled. As they're scaling quickly, they don't have time to shift. They just make sure that their key value store scales good enough. And then somebody takes a step back and says, 5? Why do we have 5? Well, at that moment, when you have 5, going from 5 to 4 is going to be a big project. You know, each one's deployed on thousands of servers. It's going to be difficult. It's going to be careful, fiddly work to go from 5 to 4, except it's really, really valuable to do that. So we can take our time with a relatively large number of engineers at that point to go from 5 to 4, and from 4 to 3, and 3 to 2, and 2 to 1. By the time you've done that, the one that's left is awesome, right? It does everything that everybody wants it to do. It's extremely reliable. It's easy to observe. It scales massively and automatically. It's fantastic. So when you get to extract and you have a little breathing room, that's the time to do infrastructure in this model. The engineering tendency is like, well, why don't we just let's have a corporate standard for the key value store. But that means that each of those explorations is going to have to wait for the corporate standard to be done. And they're not going to own it. They're going to be linked to each other, which is the last thing you want about explorations. Explorations should be completely disconnected from each other. And I don't care about the waste of the duplication of effort, because the delay involved in coordinating with other people is far more expensive than the duplicated effort. When you have scaled, that's the time to get the infrastructure exactly right. And it's a great time to do it, because you've got a big, obvious ROI. You have tons of experience. You have immediate use cases. You have lots of feedback for those projects. And that's the time that you make those infrastructure investments. Facebook did this over and over again and ended up with fantastic infrastructure, not by having somebody sit there and think carefully, but by taking the actual stuff in production and making something that's better than that was actually in production. Does that answer your question? Yeah. There's this mythology on the Google side. Google seems to sit there and think about it and then come up with the GFS or MapReduce or whatever. If you read those papers carefully, they had those failures. Oh, we implemented a web crawler and then it fell over, and we implemented another one and it fell over, and we implemented another one and it fell over. And then we realized, gah, if we just had a file system that we could distribute, then the next one would take longer to fall over. So even though it looks like Jeff Dean just sits there and meditates and comes up with fantastic infrastructure, that's a complete lie. There's iterations and cycles to that too. But somehow the message that's gotten out among architects, infrastructure people, is that we ought to be able to analyze our way to success before we have any experience, which is just the return of the waterfall. Anyway, end of. More questions? Okay, so I'll give you a quick close with a lightning round of my current ideas that I'm working on. How many of you have heard of TCR, test, commit, revert? Excellent. So this is an alternative to test-driven development. And you can implement the tooling for it on a command line. You say, run my tests, and do a git commit. So if the tests pass, you're going to make a little commit. And here's the magic part that one of my students, Oddman Strumma, came up with. Or if the tests fail, git reset -- hard. I know! Wouldn't this be incredibly annoying? Yes, that's the great thing about it. So you write some tests and you write a little bit of code to make it pass and it doesn't work and poof, the whole thing disappears. Like crap, I didn't make a mistake. Right? That's the classic. Like that was right. I don't know why the test didn't pass. So you type it in again, poof, it just disappears. So the cool thing, now you have to think, well, how can I work in smaller steps? All right, I've been a small steps guy for decades, longer than most of you have been alive. Some of you have been alive. And TCR forces me to work in much tinier steps than I've ever worked in before. It's a lot of fun. So that's one, give that a try. That feeds into another idea that I call limbo. Limbo is tiny changes instantly deployed. So let's say we're all working on some software system, and you extract out a little helper function. There is there's zero risk to the behavior of the system, right? There's no reason that extraction can't get pushed instantly to all the code that we're all working on. It's safe, it won't break anything. And there's no reason that can't get pushed to production. It's safe, it can't break anything. Now, of course, we have monitoring and canary rollouts, because when you say it can't break anything, we understand that that's a metaphor, not literally true. So you are careful with it. But what if all changes that everybody was making were instantly deployed to all the other developers and to all of production at the same time? Crazy idea, yeah? Just wait 20 years, it'll be here. Or you can start working on it now if you want to get ahead of the curve. TCR turns out is a great programming workflow to feed into Limbo style deployment. And then the last idea, the book that Dave mentioned I'm working on is called, I've always wanted to, like 10 years I wanted to write a book on software design, to really understand coupling and cohesion and power law distributions and latency, throughput, and variance. And I put it off, and I finally started working on the book. And I realized, as I always do when I start working on a book, this idea seemed like it was too small, and it's actually way too big for a book. But the seeds of the real idea that's one book's worth were in that first 2 weeks of writing that I did. And I kept coming up with this question, I want to make a change, should I tidy first? I want to change this code, it looks like crap, should I tidy it first? And the answer is, it depends. Sometimes yes, and sometimes no. So that's what I'm working on now. People keep asking me when they can expect to see the finished book, which is not the right question to ask an author. But sometime in the new year. That's all the time I have today. I'm going to be here for the conference. Please feel free to come up if any of these things that I've talked to you sparked ideas and you'd like to hear more about it, please ask me about it. And I hope you enjoy your conference. Thank you very much.